Okay, so now we're going to do a stoichiometry problem with gas. It's not too bad. Before we do it though, I just want to reiterate, so partial pressures kind of show you a real life application here. So the total pressure at ground level is 1 atmosphere, okay? And oxygen is 0.218. So at 1 atmosphere, oxygen is 0.21 atmospheres. Okay, that's how much oxygen is at 1 atmosphere pressure. Okay, so let's go to Mount Everest. We go to the top of that. The total pressure is 0.311. So instead of 1 atmosphere, it's so high, it's at 0.311. So the oxygen levels there are 0.065. So way less than the 0.21. You should have about 0.21 atmospheres of oxygen, but you're way low at 0.675. So you get hypoxia. So this is, you'll get low oxygen levels, you get dizziness, headache, shortness of breath, etc. So this is, when you go up in the mountains, and you have a hard time breathing, you might get a little dizzy. This is because the partial pressure of oxygen is a lot lower than at ground level. So you see, partial pressures are important. Another example is scuba diving. If you go 30 meters into the sea, the total pressure is 4. So remember, at ground pressure it's 1. Now it's increased to 4 when you go below it. Now the oxygen levels are at 0.84, which is extremely high because it should be at 0.21. Then you're going to start getting oxygen toxicity. Your nitrogen also gets really high. So this is why you have to be careful when you scuba dive to keep your oxygen and nitrogen levels level fine, because you're going way low under ground pressure, causing your partial pressures to increase. So increase and decrease of partial pressures can have a really big effect. So you're wondering, why do I care about this partial pressure stuff? Well, one day it could save your life. So take that into consideration. So now let's do a gas stoichiometry. So usually when you do this, you're going to, when we do like a mole-to-mole conversion, we'll do like grams to moles of A, moles of B to grams. Or if we're doing liters, we do liters to moles of A, to liters of B, to liters of B. Well, this one, usually what we have to do is use the PV equals nRT equation because it's gas. We're always going to use PV equals nRT. You're going to find moles of A and then convert that to moles of B, and then get that mole number and put that into the PV equals nRT again. So basically, you're going to use the moles to convert back and forth between the PV equals nRT. So let's look at an example here. Methanol, CH3OH, can be synthesized by the following reaction. So I can make methanol by using carbon monoxide and hydrogen gas together to produce methanol. It says what volume in liters of hydrogen gas. So right away, I know I'm trying to find volume. Of hydrogen gas in liters. That's what I'm trying to find. Measured at a temperature at 355. So I know my temperature here for my hydrogen gas is 355 Kelvin. Let's see what else I know. And a pressure of 738 millimeters of mercury. Pressure was 738 millimeters of mercury. Let me go ahead and convert that to atmospheres because I'll have to. So anytime you go to atmospheres, 760 millimeters of mercury is 1 atmosphere. So if I divide those, I know my atmospheres is 1.11. I'm just going to go ahead and do that because I know I'll have to eventually. And what other number do they give us? It is required to synthesize 35.7 grams of methanol. So methanol, CH3OH equals to 35.7 grams. Now remember, whatever I'm trying to find, that is always my B, okay? Change my color. So hydrogen, all these conditions right here for hydrogen, This is my B. Because remember, my final product, or if you want, my final answer is always my B. So then I'm starting with this, which is A. So I'm trying to go from methanol to hydrogen. So my A, again, is methanol. My B is hydrogen. So again, how did I know that? Because whatever I'm trying to find is B. Okay? So if I go back, what do I need to do? Ultimately, I need to go from moles of A to moles of B to figure out my liters, because I can plug this into PV equals nRT and get volume, which is in liters. Okay? So I'm going to go, I already have my grams, so I can easily convert that to moles. So I'm going to go, I need to find my moles of A to get to moles of B, or B is my hydrogen. So then I can plug this number here into PV equals nRT to get volume. Volume is what I'm trying to solve for. You see, moles of B will be moles right there. So let's first convert this into moles, because that's my A. So I have 35.7 grams. Remember, anytime I go from a gram to a mole, I use molecular weight, always. Molecular weight. And let me just give you, I already calculated this, the molecular weight of methanol weight is 32 grams per 1 mole. So let's go ahead and put 32 grams at the bottom, so it'll cancel out right there, per 1 mole. And this is of methanol, CH3OH. Oops. No. Why do you do this? This. Okay. Now that I have that, now I want to convert this to moles of B, right? So I'm going to go for, that gives me moles of A, and I want moles of B. So I'll put moles of A, which is my methanol, to moles of B. And remember, this is just the mole-to-mole ratio. So I'm going to have, anytime I go from moles to moles, it's the mole ratio. And I get that from the equation. So let's see. For every 1 mole of methanol, there are 2 moles of hydrogen. Just the number in front there. So 1 mole of methanol, which is down at the bottom, 2 moles of hydrogen. And that'll give me my moles, so I can plug it into PV equals nRT. So I have 35.7 multiplied by 2 divided by 32 equals to 2.23. Moles of hydrogen. Okay? But I don't want moles of hydrogen, I want volume. So now I'm going to, this mole here can now go, I don't know why I keep doing that, this mole here can now plug into right there. So let me change my color. Let's do blue. So PV equals nRT. So my pressure is 1.11, 1.11, because here's my pressure of the hydrogen gas. So PV, V, volume is what I'm trying to solve for, so I just put a V there. In, my moles I just solved for was 2.23. R is 0.0821. It's pretty much always going to be 0.0821 for this chapter. And then temperature, my temperature is right here, which is 355. So let's multiply this all out and divide by this number to get volume. So I have 2.23 multiplied by 0.0821 multiplied by 355. All that divided by 1.11. And I get my volume is 58 0.55. Let's just put 5 liters. Okay, so 3.0821 times 355. Okay. Yeah, 50.55 liters. That's how much hydrogen I need to put in this reaction to make that much methanol. Okay, so the big thing we need is moles of each. So I got moles of this, of methyl A, by just converting from moles to grams. I got moles of hydrogen by doing a mole-to-mole ratio. And then I plug that finally into PV equals nRT. So we're at the end of pretty much any gas problem, you'll use PV equals nRT. So we had P, we're trying to find V, we had T, we always have R. So that means I need N, I'm missing N. So here's my stoichiometry part here. I converted moles of A, or grams of A, into moles of B, and plug that into PV equals nRT. That pretty much concludes the chapter. Let me see if there's anything else. There's the kinetic molecular theory here. So this just says gas molecules are small, so the size of the particle is negligible. The average kinetic energy of a particle is proportional to the temperature in K, which we've already know. So as the temperature goes up, the pressure goes up. And the collisions of one particle to another particle is elastic. So they hit each other like balls. They don't, attach to each other. So it's just kind of how gas molecules react. And we've already gone over those, compressibility and diffusion. Okay. So I hope this makes sense. So gases, I think the key thing with gases is at some point you're going to use the formula PV equals nRT. Okay? There might be a few other little formulas you'll use in between there, but usually the final formula is PV equals nRT. So again, practice some problems and let me know if you need any help.